section 2.5, math 1340, page number 5, completing the square. So one of the methods to solve quadratic equations is by completing the square. Not all quadratic equations can be factored. In these cases, we may use a method known as completing the square. Using this method, we add or subtract terms to both sides of the equation until we have a perfect square trinomial on one side of the equal sign. We then apply the square root property, taking the square root for both sides of the equation. To complete the square, the leading coefficient must be equal to 1. So the leading coefficient A has to be 1. If it's not 1, we make it 1 by dividing every term by the leading coefficient in order to obtain that. Okay, so here is an example. There are steps that you can actually turn into an algorithm for you in order to follow to obtain this method or to apply this method of completing the square. So here we have a quadratic equation. The leading coefficient is 1, so we do not need to divide every term by the leading coefficient. It's already done for us. So here is the first step. You're going to take the constant to the other side. So you remove this constant. How do we remove it here? It is added, so we subtract from both sides of the equation. We subtract 1 here, we subtract 1 here. We're going to end up with x squared plus 6x equals -1. Now, we're going to add an amount that is going to make the trinomial a complete or a perfect square trinomial. That number is not a mystery. We can find it. We're going to take the middle term, b, and we're going to half it, cut it in half, and we're going to square it. So if you half the 6, you get 3. Cut the 6 in half, you get 3. If you're in doubt, just multiply 0.5 times the middle term, and that should give you the answer. And then if you square the 3, then you're gonna end up with 9. So now 9, we know, is the magic number that is gonna turn the left-hand side, which is a trinomial, into a perfect square trinomial. So we have to add it to both sides of the equation because this is an equation, a scale that we do not want to tip over. So whatever we do to the left-hand side, we do to the right-hand side. So if we add 9 to both sides of the equation, we will end up with x squared plus 6x plus 9 equals 8. -1 plus 9 is equal to 8. Now, the left-hand side can be factored in this manner. It is going to be x and x. The signs are the same, and they are the middle sign terms, so plus and plus, and then the number that goes there is the square root of the c, or the square root of the magic number we found, which is 3 and 3 in this case, equals 8, which can be written as x plus 3 all squared, because it's repeated twice, equals 8. Now, if we use the square root property, we're going to take square root here, not for this one, square root here and square root here. Don't forget positive and negative. The left-hand side is going to be x plus 3, because the square root cancels with the square. Positive or negative square root of 8, I showed you how to simplify that. It's going to be square root of, it's going to be positive or negative 2 square root of 3. Now, we want to solve for x, so we're going to subtract 3 from both sides of the equation. So we're going to rewrite it as x equals 2. You can leave it like this. Or you could say, I'm going to be fancy a little bit, so I will leave the whole number first, and then I will take the radical next. And I can split it into -3 minus 2 square root of 2, and -3 plus -2 square root of 2. So now you have 2 solutions using the square root property. Here is some examples. I don't have enough space here to solve using the completing the square method and the square root property. After that, So I will do it on a different sheet. I'll go here. We're going to do completing the square. So step number 1, the 6 must go. So we add 6 to both sides of the equation. We get x squared minus 4x plus a magic number. I'm going to leave a space for it. Equals 6 plus that same magic number. Magic number is not a magic, actually. We're going to take the 4. We don't worry about the sign. We're going to take the 4. We cut it in half and then square it. So that's exactly means like you take the 4 and then you divide it by 2 first, because PEMDAS, you do what's inside the parentheses first and then the exponents. So that is 2 squared, which is 4, which means we're going to add 4 here. We're going to add 4 here. So now the left-hand side is a perfect square. It's going to be x, the sign is minus, following the middle term sign. The number that goes here is basically the square root of this number, 2 and 2, equals 4 plus 6 is 10. We can rewrite that as x minus 2 all squared equals 10. You can skip this step since we know what it is. Now you're going to take the square root for this side, and then let me leave a little bit of space here. And then you're going to take the square root. Don't forget positive and negative. So the square root is going to cancel the square. We're going to end up with x minus 2 equals positive or negative square root of 10. We cannot simplify that because 10 is basically 2 times 5. None of these numbers are perfect squares. So now the last step is to add the 2 to both sides of the equation, which means we have the solution as x equals, I will be fancy, write the 2 first, positive or negative square root of 10, which can be split into x equals 2 plus square root of 10, and x equals 2 minus square root of 10. The second one, B. Notice how the leading coefficient is not 1. And before I do that, I'm going to rearrange the terms so the x's are together and the constant is on the other side. So that's what I'm going to do first. I'm going to add the 5. I will get 2x squared equals 3x plus 5. Now I want to bring the 3x with the 3x. So I'm going to subtract 3x from both sides. I get 2x squared minus 3x equals 5. Now, I want the leading coefficient to be 1, so I will divide every term by 2. So you'll have x squared minus 3 over 2x equals 5 over 2. Now, we're going to add the magic number. Let me actually leave a spot for the magic number. So we want to say plus some magic number equals 5 over 2 plus some magic number. That magic number is the middle term halved. So 3 over 2 times 1/2. I should do the same here. 1/2. And then we square it. So if you half it, you get 3 over 4. And then you have to square that. So we square it. We get 9 over 16. So we're going to add 9 over 16, 9 over 16 here. Okay. Now, the left-hand side is easy. We're going to say it's x minus, because the middle term is minus, and then the square root of 9 over 16 is basically that amount, so it's 3 over 4, all squared equals. The right-hand side, we need to have the same denominator. So to make 2 into 16, we have to multiply that by 8, which means we have to multiply 5 by 8 as well. So we have 40 over 16 plus 9 over 16. Now that we have the same denominator, we can add the numerators together. So we can get x minus 3 over 4 all squared equals 49 over 16. Let me actually move it over a little bit. 49 over 16. The next step is to take the square root for both sides, and don't forget we have a denominator and a numerator, so the radical should include both. So this side, these will cancel together. We get x minus 3 over 4 equals positive or negative square root of 49 is 7. Remember, it splits like that. And square root of 16 is 4. So now the last step is basically to add 3/4. So we have x equals 3/4 plus or minus 7 over 4, which now we can find the answer. If we take the addition, it's going to be x equals 10 over 4. You can simplify that or leave it. If you simplify to get x equals 5 over 2, divide both sides, divide numerator and denominator by 2. If you take the subtraction sign, you get x equals 3 minus 7 is negative 4 over 4, which is negative 1. So those are the two solutions. Last but not least, ax squared plus bx plus c equals 0. If we follow the steps, we're going to end up with the quadratic formula. So let's do it. First, we're going to subtract the c from both sides of the equation. We get ax squared plus bx equals negative c. Now we're going to divide every term by a. So we get x squared plus b over ax equals negative c over a. Now we're going to add our magic number. Our magic number is basically the middle term times 1/2, which equals b over 2a, and then we're going to square that. I'm going to leave it like that. I'm going to add it to both sides of the equation, so we get x squared plus b over ax plus b over 2a all squared equals negative c over a plus b over 2a all squared. The left-hand side is going to be x plus b over 2a all squared equals negative c over a plus b squared over 4a squared. So I will make the denominators on the right-hand side the same. So I have to multiply with a here, and I have to multiply with a, and I have to multiply with 4, and I have to multiply with 4. There. So I will get x plus b over 2a all squared equals b squared minus 4ac over 4a squared. I basically rearrange the terms, so the positive is first and the negative term is last. We're going to take the square root, both sides. Positive, negative. These will cancel. We get x plus b over 2a equals positive or negative square root b squared minus 4ac over square root of 4a squared. I basically split the radical. Now, the denominator here can be simplified because every single character is a complete square here. So we're going to say x plus b over 2a equals positive or negative square root b squared minus 4ac over 2a, because this splits into square root of 4, square root of a squared, basically. Now we're just going to subtract b over 2a from both sides. We end up with x equals, let me do it in a different color, negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Since these are the same, I can combine the numerator in one numerator. So I will have x equals negative b plus or minus square root of b squared minus 4ac over 2a, which is the quadratic formula. So now that we have the quadratic formula, we know where it came from. The quadratic formula is basically a way of solving quadratic equations when every other method fails. So if we have a quadratic equation of the form ax squared plus bx plus c, that is any quadratic equation, it can be solved using the quadratic formula if we substitute the a's and b and c instead of these. So the quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a, where a and b and c are real numbers and a is not equal to 0 because we cannot divide by 0. And if a is 0, it's no longer quadratic. The positive and negative is similar to what we get before when we get a positive answer and a negative answer. All you need to do is just know how to substitute. So let's try this method. And this method is very useful because sometimes we end up with complex numbers, and where other methods fail to find the answer, it's very easily found using this method if you are in a hurry and would like to find the answer. So some of the solutions can be complex solutions. A complex number is the sum of a real number and an imaginary number. Usually it's expressed in the standard form when it's written as a plus bi, such as a is the real part and b is the imaginary part. For example, if we have 5 plus 2i, this is a complex number where 5 is the real part and 2 is the imaginary part. Let's use the quadratic formula to practice using it. I will do one example and then I'll let you do the rest. So before you begin, you're going to figure out what A is and B is and C is. I'll do B because I see that B has a negative number, so that could be a little bit tricky. So A in this case is 1, B is equal to negative 8, and C is equal to 16. To use the quadratic formula, we write it x equals negative b plus or minus square root of b squared minus 4ac divided by 2a, which equals to b is negative 8. So negative 8 plus or minus square root of negative 8 squared. Make sure you square the negative as well. Minus 4 times a times c divided by 2 times a. So I removed every letter and I replaced it with the value. Negative 8 is positive 8 plus or minus the square root of 64 minus 16 times 4 is 64. Everything is divided by 2. So 64 minus 64 is 0. Square root of 0 is 0. So this amount is going to be 0. And then I will have the solution as 8 divided by 2, which is equal to 4. So the answer is x equals 4. And then I will do A because I think there is a complex solution there. So A is 1, B is 4, and C is 8. We will do the quadratic formula. X equals negative b, negative 4, plus or minus square root of b squared, 4 squared, minus 4ac divided by 2 times 1, which is a, equals negative 4 plus or minus square root of 16 minus 32 over 2. Yes. So this is going to be negative 4 plus or minus square root of negative 16 over 2, which will turn into negative 4 over 2 plus or minus the square root of negative 16. The negative comes out as I, and square root of 16 is 4, so 4I divided by 2. Negative 4 over 2 is negative 2, plus or minus 2I. So we have two solutions, negative 2 plus 2I, negative 2 minus 2I. Those are the two solutions that we have here. I'll leave the last one for you to practice. Finally, we're going to discuss some applications. A person has a garden that has a length of 10 feet longer than the width. Set up a quadratic equation to find the dimensions of the garden if its area is 119 square feet. So we have a garden, rectangular one, and the length is 10 feet longer than the width. So we don't know what the width is. We're going to assume it's an x. It's an unknown amount. But we know that the length is x plus 10 because it's 10 feet longer than the width. So because it's rectangular, this is going to be x and this is going to be x plus 10 as well. What do we know? We know that the area of the garden is 119, which means the area of the rectangle is 119. So we know that the area is length times width, which is x times x plus 10. And we know that the area is 119 square feet. So now this is the equation. We set it up. If we want to take it further, I'm going to distribute the x inside and then make the left-hand side 0. So this is going to be x squared plus 10x, and then minus 119 equals to 0. What are the dimensions of the garden? What are the dimensions of the garden? The dimensions of the garden depends on the value of x. So if I could find the value for x, then I will be able to find the dimensions of the width. And from that, I can find the dimensions of the length. So I'm going to try to do the math here. We're going to use the quadratic formula, of course. So we're going to plug it into the quadratic formula. We're going to say x equals to negative 10 plus or minus square root of 100, which is 10 squared, minus 4 times a times 119 divided by negative 119 divided by 2 times a, which is 1. That is negative 10 over 2 plus or minus square root of 100 plus 119, because negative times negative is positive. Everything is divided by 2 as well. I'm going to complete it here. So negative 10 over 2 is negative 5 plus or minus the square root of 219 over 2. I forgot to multiply by 4 here, by the way. So I should have said 119 times 4, and then I should add the 100 to that. 576, the square root of that is 24. So it's going to be plus 24 divided by 2, and that is 12. So you will have x equals negative 5 plus or minus 12. I know that negative 5 minus 12 is not going to work because we have a dimension. We can't have negative numbers. So the answer is going to be negative 5 plus 12, which is going to be 7. So the negative option is not going to work out, but the x is going to be negative 5 plus 12, which is equal to 7 feet. So that is the width. Now the length here is 7 feet, which means the length is going to be 7 plus 10, which is 17 feet. 17 feet. Okay. The person changes their mind and would like a right angle triangle shaped garden where the two shorter sides are the same size Assume that the area is still 119 square feet. Find the length of the three sides of the garden. So we have a triangle, and the two shorter sides are the same. And we have the area is 119. So we know that the area of a triangle is half the base times the height. Let me say just h, the height. Okay. So I know that the height is x, and I know that the base is x. So the area 119 is equal to 1/2 times the base is x times the height is x. So x squared, or half x squared, equals 119. X squared over 2. If I multiply both sides by 2 just to remove the denominator, I will get x squared equals 238 divided by, no, just 238, like that. So in order to solve this equation, we're going to take the square root for both sides of the equation. And we're not going to take negative and positive in this case because we're dealing with length. So length is not going to be negative. So the length x is approximately, if you take the square root, it's going to be 15.4 feet, approximately. And since we have a right triangle in this case, we're going to apply the Pythagorean theorem. We're going to say c squared, which is the hypotenuse square, is equal to the other legs squared, the sum of the other legs squared, a squared plus b squared. And we know that a squared plus b squared, we know the other sides, which is 15.4, 15.4. So basically we're going to say c squared, which is, this is basically c, and this is a, and this is b. So we know the length x, we found it from the previous step. So this is equal to 15.4 squared plus 15.4 squared. We're applying the Pythagorean theorem here to find out the length. So we're going to get c is equal to 15.4 square root of 2. Because it's basically 2 times that, so this is 2 times 15.4 all squared. And if you take the square root for both sides, again, we take only the positive square root because we're dealing with the length. Then we split that, it's going to be square root of 2, and then square root of 15.4 all squared. The square is going to cancel with the square root, and that's how I ended up with this number right here. Okay, hopefully the writing is clear for this one. It's kind of messed up. And the length here is in feet, of course. So we have the two legs and the hypotenuse, and we found all of the sides of the triangle from that question. And that is the conclusion of section 12.5. If you have any questions or confusions, let me know. Make sure you do your homework as soon as possible. This is how you're going to know if the concept is clear to you or you still have some questions. I'll see you in a different video.